Hello friends, my name is Swapnil Dahale. I'm going to take you through the presentation for multiple imputations, which is most widely used imputation technique for missing data in clinical trial. And I'm going to explain you how we are implementing multiple imputations using SAS. So the agenda is imputation methods for missing data, which are currently available, and traditional methods. And I think most of us are already aware of that. Disadvantages of traditional methods, which we called as single imputation methods, then missing data mechanism, multiple imputation and its implementations using SAS. Last but not least, points to remember. So these are the three traditional techniques which we generally used for handling of missing values in case of continuous data. One is LOCF. LOCF is nothing but last observation carry forward, where we are imputing missing data with the last non-missing available results. Second, average of non-missing results, where we are imputing missing data with the average of non-missing results. Third, BOCF, baseline observation carry forward, where we are imputing missing results by baseline. In this slide, I have included some of the disadvantages of traditional single imputation method, which we discussed earlier. Some of the potential disadvantages of single imputation method are listed below. First, LOCF makes an assumption that observation of an individual has not changed at all since the last measure observation, which is mostly unrealistic in clinical trials because in lab parameters we are expected to change the results over time. Then average method are risk biasing and standard error downwards by uh, ignoring the uncertainty of imputed values. Therefore, the confidence intervals for the treatment effect calculated using average may be too narrow and give an artificial impression of precision that does not really exist. This possibility should be addressed when results from these analyses are presented. Obviously, when we are replacing missing values by an average of non-missing data, we do reduce the standard error, and ultimately it will affect the confidence interval, and we are getting narrower confidence interval in that case. Third, BOCF method assumes that there is no change in the results from baseline, which is also unrealistic in most of the cases, for example in lab, as I told you earlier. In this slide, I have included some of the missing data mechanisms. First is missing completely at random, where we are assuming that there is no relationship of missingness to any other parameters or any other variables in the dataset. Second, missing at random, it assumes that there should be some relationship with the predictors and missingness. Third, missing not at random assumes that missing values on the variables are related to values of that variable itself. In this slide, I have included one example to explain missing data mechanism in simplified format. Suppose you are modeling weight as a dependent variable based on function of gender as an independent variable. Some responders wouldn't disclose their weight, and unfortunately you'll get missing Y variable results. I think there are three possible mechanisms for non-disclosure of weight. One, there may be no particular reasons why some responders told you their weight and some didn't. In this case, you will consider data as missing completely at random, or MCAR. In second scenario, one particular gender group may less likely to disclose their weights, for example, females. In that case, you will consider this as a missing at random. In third scenario, particular weight group patient like heavy or light people may less likely to disclose their weight. In that case, you will consider that as a non-missing at random or missing not at random. You can see in this figure, I have included all these scenarios using graphical representation. For missing completely at random, you can see there is no relationship between X and Y variable with missingness. In missing at random, here X variables taken part of missingness of your Y variable, and in third missing not at random, here Y is also taking some part for the missingness of your data. Here I'm going to discuss multiple imputation methods for missing at random. Okay, so a multiple imputation procedure replaces each missing value with the set of possible values that represents uncertainty about the right value to impute. The multiple imputed data sets are then analyzed using standard procedure for complete data and combining results from these analyses by imputation number. Third, no matter which complete data analysis is used, the processes to combine results from different data sets are essentially the same in multiple imputation using Rubin's rule. Here you can probably get more idea how multiple imputation mechanisms is work. So if you can see, we have data set with missing values. Okay, what multiple imputation is doing, it creates set of m data sets, and in each data set it replaces missing values with the help of observed data distribution for your data set. Here you can see filling missing values with the values from drawn distribution of your data, and then it moves to second part where we are analyzing the results based on imputed values for m number of data set. And third, we are combining them using simple formula of Rubin's rule and represented the estimates of treatment groups. In next slides, you'll find this this is simple mechanism. Okay, so let me go to next slide. In this slide, I have included flowchart for multiple imputation procedures to be followed. I mean data step to be followed for multiple imputation. First is a data step where we are creating single row per subject and sort them by treatment group. In step 2, we are using PROC-MI to create multiple imputation datasets using AMI procedure. And then sort them by imputation number. In step 4, we need to perform the planned analysis as per your requirement for m number of datasets. And last, you need to combine them using PROC-MI analyze to have overall estimates with confidence interval that adequately reflects the uncertainty due to missing data. I'll take you through one example for the multiple imputations using SAS. So for that, I have included one dummy data set where you can find some of the missing values for subject number 2, week 8, 12, 24, 52 are missing for that particular subject. In this case, I'll try to explain how multiple imputation is work and procedures or SAS codes in next slides. So as a part of step 1, we need to create dataset with a single row per subject using SAS procedure. Proc transpose. So you can see I have included SAS procedures as well and SAS code for your reference. After performing proc transpose on original data, if you can see subject number 2 is reflected with the missing results at week 8, 12, 24, 40 and 52. Whereas on the same path, we have missing results for subject number 4 at week 24, 40 and 52. We can move to step 2 in next slide. As discussed in flowchart, in step 2, we need to sort the data before applying multiple imputation. So we need to sort the data first before applying multiple imputation, then create multiple imputation dataset using SAS procedure PROC-MI. I have applied proc sort procedure on the dataset created in step 1. And in PROC-MI, I have used variable which I want to impute with multiple imputation and by treatment. So it will consider different distribution by treatment group to impute the variables which you have defined in the PROC-MI procedure. This is the data set which I'm getting after using PROC-MI. In this data set, you can find results for subject number 2 are replaced with the non-missing results using ProcMI. Same for subject number 4. But here in this data set, we have another column appeared as imputation number. This is related with the number of imputations you have defined in ProcMI. So it is creating 100 number of data sets with different values for each treatment group where we have missing values. We can proceed with step number 3. In step 3, we need to perform planned analysis as per our requirement, and we need to perform the planned analysis by imputation number and store the estimates and standard errors in another SAS dataset. Here you can see I have included code, SAS code or SAS procedures for perform the analysis as per your requirement. Before proceeding for the analysis, I have sought multiple imputation dataset created in step 2. So if you can see, I have included by imputation in ProcMI. So we will have estimates and standard errors by imputation number. You can see I have included them in the dataset. Also, I want to perform mixed modeling using baseline weight category and treatment as an independent factor for week 52 data. Also, I have stored these data sets, estimates and standard error in estimate dataset. This is the last step or step number 4, where we are combining results for all imputations like estimate and standard error using MI analyze procedure, and while combining those results, the Rubin's rule is applied. How it will be produced using SAS procedure, I have included one example for that, or SAS code. So in model effects, I have included estimate, and in standard error, I have included standard error variable, and it will give us the estimate, final estimate for our data set based on multiple imputation procedures or dataset created using multiple imputations. You can see I have used ProcMI analyze to combine 100 dataset and to create one single estimate and standard error corresponding to week 52. In this slide, I have contained the information regarding points to be remembered before considering multiple imputation or before applying multiple imputations using SAS. So point number 1 is multiple imputation is time consuming when you will have large number of imputation. In our example, I have considered number of imputations as 100, but if you increase that number and in If your study or parameters are more, then it will be time consuming to run ProcMI. Point number two, in case of large number of variables, we may face convergence issues. If you remember, I have added some of the options for convergence which you can consider in case of convergence issues while modeling. Point number three, MI should not be used as primary analysis, and it can be used as a sensitivity analysis because we are dealing with the distribution of observed data in multiple imputation. Point number four, we need to pay attention while interpreting the results when we will have more than 30% data missing for each category. Point number five is none of the method is appropriate in case of large missing data. You can consider this as an assignment to compare the results of MI, LOCF, BOCF, and average replacements using our software or any other software which you can prefer, and this will help you to understand how promising results MI is estimated. I hope you you all find this presentation useful to start off with multiple imputation. So thank you.